Hello, my name is Dante Hodge. Welcome to my Fundamentals of Physics podcast for Corey's class this month. Today, I will be talking about Newton's laws of motion. The purpose of this is to give you a broader understanding of how it all works. First, we have to understand what is motion. Motion is a change in position of an object with respect to time. Sir Isaac Newton, an English scientist and mathematician, was born on the 25th of December, 1642, and passed on the 20th of March, 1727. It is because of his brilliant discoveries we understand how motion and gravity work. Today, we are going to focus mainly on his laws of motion. His first law states that an object at rest remains at rest, and an object in motion remains in motion at constant speed and in a straight line unless acted on by an unbalanced force. Here are two examples of this law in action.
In this clip, the bike on the ground is at rest, and unless acted on by an unbalanced force, it will stay there forever. In this case, I am the unbalanced force, picking up the bike and moving it. In this clip, the bike is moving at a constant speed in a straight line, and it would stay at this pace, but because of the friction caused by the ground and air resistance, the bike slows down.
Newton's second law states that the acceleration produced by a net force on an object is directly proportional to the net force, is in the same direction as the net force, and is inversely proportional to the mass of the object. What this all really means is that the more force applied to an object, the faster it will accelerate. The less force applied, the slower it will accelerate. And as the mass increases, even if the same amount of force is applied, the object will accelerate slower. Here's a video of this law in action.
This clip shows that the more force applied, the faster I accelerated. And this one shows that when less force was applied, I accelerated slower. These two clips show the difference in acceleration when the same amount of force is applied for the same amount of time but the masses change. The first rider had less mass and accelerated quicker than the rider with more mass, even though the same amount of force was applied.
Newton's third and final law states that whenever one object exerts force on a second object, the second object exerts an equal and opposite force on the first. Easier put, to every action there is always an opposed equal reaction. Here's an example of this law in action.
In this clip, I am applying force on the wall, and even though I can't feel it, the wall is applying the same amount of force on me.
Thank you for watching my podcast.
If my force
I hope you
exceeded that of
enjoyed
the
it
walls,
and gained a better understanding of how motion works and how physics is used in everything we do, even though we're not aware of it. See you again till next time. Peace.